Okay, now that we have seen what the different symbols in a conceptual data model or an ER diagram consist of, namely entities and relationships, and what are the different symbols that are used to represent relationships. So now that we know what these symbols are in this in the ER data model, let's go ahead and do some very simple exercises to actually convert requirements to the conceptual model. So what we have seen in the previous video is what are the symbols that go into the conceptual data model. So when we represent the conceptual data model as an ER diagram, what are the different symbols that are used? What do those symbols mean? So in this tutorial, we will actually take baby steps for going from requirements analysis to the conceptual data model itself. So we're looking at this process, the modeling process itself. So we'll start from requirements and come up with the ER diagram for very simple requirements. Okay, so here we go. I'm trying to find the examples over here. Okay, so here are so imagine that these are the requirements that have been given to you. Of course, in real life, the requirements will be much more complicated and stated very vaguely by in an imprecise way by end users. So how to get from those real life requirements specifications to a data model, we will see in a different video, but here we're taking baby steps in that direction. Okay, so imagine that somebody tells you that we want to store information about employees and offices, and they tell you these two things, that an employee may manage an office and an office is managed by one employee. So that's the only information that's given to you. Now, just from this requirement, it should be apparent that there are two things, two entities about which we want to store information. Okay, one is a thing or an entity called an employee. And we can write down some attributes of this employee. It doesn't have to be too many. So let's say an employee ID number, name, and date of birth. You could think of other attributes as well, but these three attributes will do for this entity called employee. And you go back to the requirements. You have the second entity, second thing about which we are going to store information, and that's called an office. So I'm representing it by the rect. Remember, entities are represented by boxes. So here is the name of the entity, and it will have some attributes as well. So maybe building number, room number, okay, and size of the office, how many square feet, let's say. You can think of other attributes of the office, which floor it is on, and things like that. Okay, but so we have these two entities, and our main interest here is capturing the relationship between these two entities. And what the requirements tell us is that an employee may manage an office and an office is managed by one employee. So the relationship between these two entities is manage. So I write the word managers because every relationship must have a name. Okay, so I draw this dotted line between these two entities, and we're using the crow's foot notation. So I know that there is a relationship between employee and office. So this is a binary relationship, a relationship between two entities. But now we have to show the cardinalities in this picture as well. We want to capture all this, the relationship. So an employee may manage an office. Okay, so let's come back to this example. So one employee may manage an office. So at the most, an employee will manage one office. And when you read the word may, it suggests to you that an employee need not be managing an office. Okay. So I will put the 0 over here. So the way I read this picture is one employee manages at least 0 offices and at most 1 office. So no employee will manage more than 1 office. So this is the maximum cardinality over here. And this inside symbol is the minimum cardinality. So one employee manages at least 0 offices and at most 1 office. So where did I get all that from? It's just from this one sentence here. It says an employee may manage an office. So one, and may means that you could have an employee who doesn't manage an office. All right. So that's one piece of the relationship. Now here's another one. An office is managed by 1 employee. Okay, so if you look at the wording of this, it's telling me that if you have an office, it has to be managed by 1 employee. So how do I represent that? I will represent it using 2 bars. Why? Because based on the text that you just read, the way I'm reading it, interpreting it is if I go from right to left, 1 office is managed by at least, so this is the at least, minimum cardinality, at least 1 employee and at most 1 employee. So you can't have an office managed by more than 1 employee, and you can't have an unmanaged office either. So if there's an office, it has to be managed by an employee. So this is where how I represent the at least and the at most, the minimum and the maximum cardinalities. So the minimum cardinalities are represented by the inner symbols, and the maximum cardinalities are represented by the outer symbols at the 2 ends of the relationship line in a crow's foot diagram. Okay, so let's continue with some more examples. So we have faculty and offerings. So again, just by reading this narrative, it tells me that there are 2 entities between which we want to capture a relationship. So let me just write, and this time I won't bother with the attributes. I'll just write faculty. And here is the entity called offering. So there are 2 entities and they are related. The content is related. So it says a faculty may teach many offerings. An offering can be taught by at most 1 faculty. Okay, so there's a relationship between faculty and offering, and that relationship is teaches. So I represent that relationship by this dotted line and I put a name on the line because every relationship must have a name. So now I have to put the minimum and maximum cardinality at the 2 ends of this relationship line, and I go back to the narrative and see what it tells me about the relationship. It says a faculty may teach many offerings or no offerings. All right, so that means 1 faculty teaches at least 0 offerings. Do you see it says the faculty may teach nothing, and at most many offerings. Okay, so 1 faculty member teaches, I'm going from left to right, 1 faculty member teaches at least 0 offerings and at most many offerings. So do you see the minimum and maximum? Here's the minimum cardinality, here's the maximum cardinality. The inside symbol is the minimum cardinality and the outer symbol is the maximum cardinality. Okay, and I got these symbols from the requirements. The requirement says a faculty may teach many offerings or no offering. Now let's go in the reverse direction. An offering can be taught by at most 1 faculty. Okay, it doesn't say it has to be taught. So again, this is my interpretation. When I go from right to left, we'll say 1 offering can be taught by, now again, it's possible that you can have an offering without a faculty at the beginning, but ultimately you would have to assign a faculty member to teach the offering. So we'll say 1 offering is taught by at least 0 faculty members and at most one faculty member. Okay, so at least 0 and at most 1. You can't have an offering taught by more than one faculty. That's what the narrative is telling us. It's at most 1. Okay, now if this is a university that allows team teaching, it could say an offering can be taught by at most 2 faculty, okay, or at most 3 faculty, in which case we would have to put many in the symbols. But so when we go from right to left, the way we interpret this relationship is one offering is taught by at least 0 and at most 1. So the inner symbol is the minimum cardinality and the outer symbol is the maximum cardinality. Now suppose this rule, this description, this requirements had been made more specific or more stringent. Suppose it said that an offering has to be taught by at least one faculty and at most one faculty. In that case, I wouldn't put the 0 over here. I would put a 1, because one offering has to be taught by at least one faculty and at most one faculty. Okay, so whatever symbols you use in the ER diagram, they have to reflect the reality of the application that you're trying to model. Okay, so let's look at this third example over here. Where's this? I'm sorry, here's the third example. So now you have a relationship between student and offering. So now you have another entity. So let's say student. Again, what is this description telling us about the student? A student may enroll in many offerings or no offering. And a particular offering may have several students enrolled. Okay, so coming back to our diagram, so we'll say enroll. That's the relationship between student and offerings. So I draw a dotted line between student and offering. Okay, so now I got to capture the cardinalities that are present in the relationship. So let's go back to the text. It says a student may enroll in many offerings or no offerings. Okay, so let's go from left to right. One student, so I'm going in this direction now. One student may enroll in at least 0 and at most many offerings. So do you see the inner symbol is the at least and the outer symbol is the at most in terms of cardinalities. So let me just repeat where I got those two symbols from. You look at the text. A student may enroll in at least 0 offerings and at most many offerings. Okay, now if we go in the reverse direction, a particular offering may have several students enrolled. Okay, so coming back here, so one offering may have at least 0 students enrolled and at most many students enrolled. So that's where the minimum and the maximum cardinalities come from, and I got them from the text. So a particular offering may have several, so many students enrolled. Now it doesn't explicitly tell us that a particular offering may have no students enrolled, but I'm assuming that's as a possibility. Okay, so because that's what happens in real life when an offering is put on the registrar's website. You know, for some time there may be no students who have enrolled in that particular offering. Okay, so an offering enrolls at least 0 and at most many students. So the inner symbol is the inner symbol is the minimum. What's happening over here? Oh, sorry. So the inner symbol is the minimum and the outer symbol is the maximum cardinality. Okay, so I hope you're gradually seeing how one goes from requirements, the contents of the database that are expressed to you in textual form, or end users tell you what the information content is going to be, and the information content is represented as a conceptual data model, which consists of entities and relationships. So let's see one more example. So you have here's a requirement that's given to you. A student may be assigned to one advisor. An advisor may advise many students. Okay, so these are the attributes of the entity called student: G number, name, date of birth, and address. For the advisor, you also have a G number, name, department, phone, and email. So these are the two entities, and there is some kind of relationship between the two. Okay, so let's see how we represented it. So here is your entity called advisor. Here is the entity called student. Okay, so notice that the attributes have been listed for the entity, and the identifier for every entity must have an identifier. That identifier has been listed and underlined. Okay, so you can see there's the identifier for advisor, and you saw the identifier for the student as well. And there's a relationship between these two entities called advise. So you have this dotted line which indicates that there is a relationship between advisor and student. Since this relationship called advise connects two entities, it's a binary relationship. The only thing that remains is what are the cardinalities. Okay, how many? Remember, the word cardinality means how many. It's some kind of a count. Okay, so what did the text tell us? It says a student may be assigned to one advisor. May means a student may not be assigned to any advisor at all. So do you see, a student can be assigned to at least 0 advisors and at most 1. So if I blow up this particular symbol, it's a 0 and a 1. Do you see? So a student can be assigned to at least 0 and at most 1 advisor. The inner symbol is the minimum cardinality, and the outer symbol is the maximum cardinality. So going back to my text, a student may be assigned to one advisor. So the student may not be assigned to any advisor at all. So it's just by reading this text, this requirements of the content, database content, tells me a student is assigned to at least 0 advisors, but at most 1 advisor. Now, if you think in the reverse direction, an advisor may advise many students. May means you can have an advisor who has no students that they're advising, but they also may have many students. So coming back in the other direction, so we go from advisor to student, left to right. So one advisor advises at least 0 and at most many. So if you blow up this particular picture, you have the at least 0 and at most many. So one advisor, coming from left to right, one advisor advises at least 0 students and at most many students. So in this picture, you see the ER, entity relationship representation of the textual requirements that was given to you. Okay, so let's take another requirement here. This is something that you get by talking to end users and analyzing the application. So these are requirements stated in textual form. So a customer may place many orders, and an order is placed by one customer. Okay, so you have an entity called customer, and these are the attributes: customer number, customer name, customer address. And you have an entity called order. It's order number, order date, order city, order state, and order zip. Okay, and then you can have an employee. Here's a third entity: employee number, employee name, employee phone number, employee email, may handle many orders, so on and so forth. So if you look at this entire description here, you can see that there are at least 3 entities. So now actually there are 4 entities. There is customer, there's order, there's employee, and there are products. So there are 4 things about which you're storing information in the database. And for each one of those things, the attributes have been given to you. So how do we represent that first? So you go back to the picture, the ER diagram. That's this portion here. So you can see these 4 boxes. Okay, each entity is represented by a box, a rectangle. Okay, and the entity has a name. Every entity must have a name. You have a list of the attributes of the entity, and of course there is an identifier for each entity. So in the case of employee, it's an employee number. In the case of order, it's the order number. In the case of customer, it's the customer number. So those are the entities, those are the boxes, the rectangles in the ER diagram. Now let's go back and read the text once again. It says, a customer, so you have a relationship between customer and order. That's what this sentence is saying. A customer may place many orders. So if you parse that sentence, what it is saying is a customer may place 0 orders. May means they may not have any order, but they also may place many orders. Okay. So look at the relationship between customer and order. If we go from left to right, a customer may place at least 0 orders and at most many. Okay, so the inside symbol is the at least, and the outside symbol on the line on the relationship is the maximum cardinality. So if we explode that picture, it looks like this. So one customer places at least 0 and at most many orders. Okay. Now if you go in the reverse direction, you must always complete a relationship by going in both directions. Now if you go back to the narrative, okay, it says an order is placed by one customer. You can't have an order that's placed by multiple customers. That's what the requirements is telling you. So let's see how that's represented in the ER diagram. If you go from order to customer, an order is placed by, again, if I blow up this particular picture, part of the picture, it's got 2 vertical lines. So an order is placed by at least one customer and at most one customer. So the inside symbol is the minimum cardinality and the outside symbol is the maximum cardinality. Okay, so this is a one-to-many relationship. Now let's go back to the, so gradually we are going to build up this picture. So right now we have our 4 entities and we have figured out one relationship up to now. Okay, let's go back to the narrative and see what it says. It says an employee may handle many orders. So you can have an employee who hasn't handled any orders, but they may also handle multiple orders. So let's see. This is a relationship between employee and order. Okay, so one employee, if I go from right to left, one employee handles, that's the name of the relationship, handles at least 0 and at most many orders. So if you blow up that left side of that dotted line, you're seeing this, isn't it? This is handles, the relationship handles. So one employee handles at least 0 and at most many orders. Let's go back in the rest of the narrative. It says an order must be handled by one employee. So let's see what the picture says. If you go from right to left now, one order is handled by at least one and at most one employee. Okay, so that's where the 1 and 1 came from. So we have that particular relation, this particular relationship taken care of now. The only thing that remains is the third relationship. Let's see what the text tells us. Here's the text, the narrative, the requirements. It tells us that an order can contain many products and a product can be purchased in many orders. So an order can contain many products. Now, it would be very strange if you had an order with no products. Okay, so when we go from order to product, let's go in this direction. We'll say one order contains at least 0 and at most many products. So if I blow up this particular part of the picture, it looks like this. Okay, so one order contains at least one and at most many products. Because just imagine that you receive an order and it has no product in it. That doesn't make any sense. Okay, so an order should have at least one product, and that's why you see this bar, which actually it's a sideways 1 actually. Now if you go in the reverse direction, you could have a product that has not been ordered, isn't it? That's perfectly reasonable. So if you look at the narrative, it says a product can be purchased in many orders. Can be means you could have a product that might not be purchased in any order, but it could also be purchased in many orders. Okay, so if I go in the reverse direction, we have one product can be contained in at least 0 and at most many orders. So if I blow up this particular part of the line, it looks like this. Okay, so this is contains, this is the relationship contains. Okay, so going from product to order, we'll say one product is contained in at least 0 and at most many orders. Okay, so I hope now you are seeing not only how these symbols are used, these symbols for entities, for relationships, cardinalities, but how one gradually goes from requirements to the conceptual model, the entity relationship diagram. So just to summarize, the symbols that are used in an entity relationship diagram, you have rectangles that represent entities, you have lines, dotted lines that represent relationships. Every relationship must have a name, and every relationship must specify minimum and maximum cardinalities. Okay, so there are two aspects of relationships. One is how many entities they connect. There you have, that's the degree of the relationship. So you could have unary, binary, ternary relationship. By far the most common type of relationship is the binary relationship. And then the other property of a relationship is its cardinality, that is how many of each of these entities are connected to one another. So there you have 1:1, 1:many, many-to-many relationships, and we have just gone through an exercise to show you how those different kinds of relationships are represented using the crow's foot notation.